With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Let us start with the question. The question says that the light is incident from the glass of refractive index 1.5 to air. Sketch the variation of the angle of deviation delta with the angle of incident I, for which the I varies from 0 to 90 degree. So basically what we have to do? We have to draw a graph between delta and I. So if we get the values of the delta and I, then it will be easy for us to draw the graph. So let us see the condition. Let the light is traveling from denser medium to rarer medium. Let this is the interface and the light is passing from denser to rarer medium. Let the angle of incidence is I and the angle of refraction is R, and this is our angle of deviation delta. So delta is what? Angle of refraction minus angle of incidence. So we get a relation between them. Now if angle of incidence is equals to 0, that is the light is passing through normal and it goes through normal, so delta is equals to 0, right? So for I is equals to 0, delta is equals to 0, and this is the case when the angle of incidence is minimum. Now taking the case when angle of incidence is maximum. Angle of incidence is maximum when I is equals to C, where C is the critical angle. So this is the case of maximum angle of incidence. So when angle of incidence is critical angle, then delta is equals to R minus C. But when the angle of incidence is equals to critical angle, then the angle of refraction, that is R, is equals to 90 degree. So delta will be 90 degree minus C, or we can say delta is equals to pi by 2 minus C. Therefore, for I is equals to C, delta is equals to pi by 2 minus C, right? And now if the angle of incidence is greater than critical angle, then what will happen? So we can study over here. Let this be the interface and this is our normal, and when the light is incident to more than the angle of critical, so what will happen? The light will bend and reflection occurs. Okay, so this would be the path if the light would be refracted. So let this angle be I, then angle of incidence is equals to angle of reflection. Therefore this angle is equals to I. So this angle is equals to 90 degree minus I, and this angle will also be equals to 90 degree minus I. Therefore this is the total deviation, right? So in this case, total deviation delta is equals to 90 degree minus I plus 90 degree minus I. This implies 180 degree minus 2I. Or we can write delta is equals to pi minus 2I. Right? So here we write angle of incidence is greater than critical angle. Then this is pi minus 2 times of critical angle. So now let us draw the graph. So let this be R, the angle of incidence, and this is the angle of deviation. So when the angle of incidence is 0, then angle of deviation is also 0. When angle of incidence is equals to critical angle, then the value of delta is pi by 2 minus c. So let this be this point. So what will happen during this time? During this time, the graph will goes on increasing, right? But when we increase the angle of incidence greater than critical angle, then it will jump to angle of deviation pi minus 2c. So for slightly greater than c value, the graph will jump this place. Okay. And after increasing this value, when we increase the angle of incidence continuously, then the graph will goes on decreasing continuously. So this will be our sketch. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.